Hello everyone, welcome to the live session presentation for structure, form and architecture, the synergy. Today we will be doing week 6 assignment 6. This is an NPTEL course by Professor Subhajit Sadhu Khan, and yeah, let's get started. So I explain these terms in every session, so I will be skipping this today. So the syllabus covered in week 6 was shell structures, trusses and space frames, folded plate structures, membrane structures, pneumatic structures. Without any further ado, we will start with the questions. Question number 1. The following is an example of membrane structure, shell structure, folded plate structure, pneumatic structure. So, what is membrane structure? A membrane structure is a structure with a thin, flexible surface or a membrane which carries load primarily through tensile stresses. A structure that is characterized by a tensioning of the membrane system, typically with a wire or cable, to provide the critical structural support to the structure. As per structural and architectural point of view, membrane structures are light and free-form structures to span long distances with the minimum material used in their manufacturing. Membrane can be used to construct roofs and facades, freestanding buildings, building envelopes, skylights, indoor ceilings, or accent closures. So what happens in membrane structures is that a flexible surface, usually that of a fabric, is used, which is supported by a cable and mast, and the fabric uses tensile trusses to carry the load. Shell structure, excuse me. Shell is a type of building enclosure. Shells belong to the family of arches. They can be defined as curved or angled structures capable of transmitting loads in more than two directions to support. A thin curved plate structure shaped to transmit applied forces by compressive tensile and shear stresses that act in the plane of the surface. They are usually constructed of concrete reinforced with steel mesh, and it functions both as structure and covering. A shell with one curved surface is known as a vault. A shell with doubly curved surface is known as a dome, double curvature. More complex forms of concrete shells have been made, including hyperbolic paraboloids or saddle shapes and intersecting parabolic voutes. So shell is a thin concrete structure which is used, which is curved, and it uses tensile, compressive and shear stresses, and it has a lot of curves in its form. A single curvature shell is a vault, a double curvature shell is a dome, and then there are very complex forms of shells which includes hyperbolic paraboloids, etc. Then what is a pneumatic structure? A pneumatic structure is a membrane structure which is stabilized by the pressure of compressed air. Pneumatic structures are characterized by slightly higher pressure of internal air above the outside pressure. These structures are supported by pressurized air within the inflated building elements that are shaped to carry loads in a traditional manner. The roof membrane of the pneumatic structure is made from rubber or reinforced films using industrial fabrics coated with polymers like PTFE. Folded plate structure. Folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges. In this way, the structural system is capable of carrying loads without the need for additional supporting beams along mutual edges. This technique originated in Germany in the 1920s and became popular to construct roofs for industrial warehouses and public buildings. Modern folded plate structures are typically made of cast in situ or precast reinforced concrete or steel plate. So our answer is folded plate structure. So this image was given and you were supposed to identify which this image would fall category into. So the shape of this leaf shown in this image, it looks very similar to the folded plate structure. Question number 2. This again one curvature has been given and you are supposed to identify which kind of curvature is it. Monoclastic, synclastic, anticlastic or bipolar. Monoclastic, so monoclastic is a single curvature shell which can be curved in one direction and it comes in the form of barrel vaults or conoid shells. Synclastic These shells are doubly curved and have similar curvature in each direction. Synclastic surfaces are those in which the center of curvature are on the same side of the surface. A dome is a good example of a synclastic shell. It is doubly curved and can be formed by rotating a curved line along an axis. Anticlastic. Anticlastic surfaces are those in which the centers of curvatures are located on opposing sides of the surfaces. Anclastic shells are doubly curved, but each of the two curves have opposite direction to the other. Example, saddle points, conoids, hyperbolic paraboloid and hyperboloids. They are all considered to be anticlastic shells because they are saddle shaped with different curvature in each direction, and straight lines can be drawn of the surface. This is commonly described as a saddle shape. So in monoclastic there is only one curvature, and in synclastic there are two curvatures, but the center of both the curvatures is in the same direction. And in anticlastic there are two curvatures, but the center of both the curvatures is in opposite directions, which makes this anticlastic curvature look like a saddle shape. So this is how monoclastic, synclastic and anticlastic look like. So coming back to the question and coming back to the image, this is this image. The figure has the curved surface has two curvatures and both are in the same direction, so it is a synclastic curvature. Question number 3. SkySong at Arizona State University campus is a dash tensile structure: high bar, conic, vault or inflatable. So this is how the SkySong structure at Arizona University looks like. It is a mixed use project. It consists of 1.2 million square feet of office, research and retail space and a hotel conference center. And this is apparently the entry for that area. So what is a conical tension structure? Highly effective for covering large areas. A conical tension structure is easily identified by its tent-like shape. Conical designs can feature either single or multiple masts. For both design options, membranes are tensioned between a ring at the pinnacle and the perimeter support columns. Cones are specially effective in areas that need to comply with high rain or snow load regulations. High power or anticlastic structure. As one of the most common of all tension membrane structures due to its aesthetically pleasing look, hyperbolic shapes are notable for their excellence with shape retention and water runoff. These structures rely on two opposing curvatures known as anticlastic for their stability. This type of structure is ideal for a shade over seating areas or high traffic walkways. Parallel arch or barrel vault structure. These symmetrical curved parallel arch designs form an incredibly functional tension membrane canopy that can span long distances such as a sports arena or smaller areas such as entryway. Depending on the spans, a barrel vault system can be a cost-effective way to incorporate the tensile membrane on a project due to repetitive nature of the design and efficiencies of MAPES. Inflatable structure. Most commonly used as biodome and for users to set up a temporary exhibition hall using pneumatic air inflating method. So this is how a high park looks like, this is how a barrel vault looks like, this is how conic and inflatable, all four types of structures will look like. So going back to the image of SkySong Arizona, it's very clear that it is conic type tensile structure. Question number 4. The Millennium Dome in London is an appropriate example of dash structure: membrane, folded plate, pneumatic, diagram. So Millennium Dome is a large dome-shaped building on the Greenwich Peninsula in southeast London, England, which housed a major exhibition celebrating the beginning of the third millennium. As of 2022, it is the 9th largest building in the world by usable volume. It was opened in 31st December 1999. It is 95-meter high. The architectural style comes in high-tech architecture. The architects were Richard Rogers and Mike Davies. So membrane structure. I explained in the previous question, and also I explained folded structure, what folded plate structure is, and pneumatic structure is. All three were explained in the previous question. Coming to diagrid. A diagrid is a framework of diagonally intersecting metal, concrete or wooden beams that is used in the construction of buildings and roofs. It requires less structural steel than a conventional steel frame. Hearst Star in New York City, which is an example of diagrid structure. It was designed by Norman Foster. It uses 21% less steel than a standard design. The diagrid obviates the need of columns and can be used to make large column-free expanses of roofing. So our answer is that Millennium Dome in London is an appropriate example of membrane structure because it's a dome with a membrane structure. It has different masts and cables which are holding the tensile structure, and the curved surface of the fabric structure, or the tension fabric, is taking the load. So the answer is 4. Yeah, it's an example of membrane structure. Question number 5. The following illustration is of a Warren truss, Baltimore truss, bowstring truss, Harvey truss. So I have explained these things. Pratt truss. In a Pratt truss, the vertical members are in compression while the diagonal members are in tension. This simplifies and produces a more efficient design since the steel in the diagonal members can be reduced. Warren truss. Warren truss is a very popular truss structure system, and it is identified by its construction from equilateral triangles. One of the main advantage of a Warren truss is its ability to spread the load evenly across a number of different members. Baltimore truss. The Baltimore truss is a subclass of the Pratt truss. A Baltimore truss has traditional bracing in the lower section of the truss to prevent buckling in the compression members and to control deflection. It is mainly used for rail bridges, showing off a simple and very strong design. Bowstring truss. A bowstring truss is a structural device commonly used in bridge building and less often in industrial architecture. It is used to span wide column-free spaces, and it consists of an arched beam, the bow, joined at each end by a straight beam, the string. The diagonal support beams joining the two. Harvey truss. Harvey trusses are essentially the opposite of Pratt trusses in terms of geometry. In fact, looking at a Pratt truss upside down will visualize a Harvey truss. The entire structure is still relatively the same, but the diagonal braces are now occupying the opposite or the unoccupied joints. This switch in position of the diagonal members has a very important effect structurally. So this is how Warren truss looks like. It is formed by equilateral triangles. And then we have Baltimore truss, which is a subclass of Pratt truss, but it has more bracing in the lower part, more diagonal bracings with half-length verticals and diagonals. And then coming to Pratt truss and Harvey truss, you see Harvey truss is opposite of Pratt truss. It's like they are mirror images in terms of bracing angles. And then bowstring truss, the upper part is curved and the lower part is straight, and then diagonal braces in between them. So coming back to the image again, we were supposed to identify which of the following, what is this truss. So the answer is A, Warren truss, because it has equilateral triangles and it is equally distributed, so it is Baltimore truss. Pratt truss has some vertical members. Warren truss does not have any vertical members. Question number 6. In which of the following building folded plate structure was used? Bihar Museum, Patna, Church of Notre Dame de Royan, France, Yokohama International Port Terminal, Japan, both B and C. So folded plate structures, they are basically assemblies of flat plates or slabs which are inclined in different directions and joined along their longitudinal edges. In this way, the structural system is capable of carrying loads without the need for additional supporting beams along mutual edges. This technique originated in Germany in the 1920s, and it became popular to construct roofs for industrial warehouses and public buildings. Modern folded plate structures are typically made of cast in situ or precast reinforced concrete or steel plates. So this is images of the mentioned buildings. Bihar Museum, Patna, Church of Notre Dame de Royan, France, and then Yokohama International Port Terminal, Japan. So the question was that in which of the following buildings folded plate structure was used? So the answer is D, both B and C, Church of Notre Dame de Royan and Yokohama International Port Terminal. Both of the buildings have folded plate structures. Question number 7. Shenzhen Universiade Sports Center in China is an example of arch structure, folded plate structure, pneumatic structure, dome structure. So this is how the Shenzhen Universiade Sports Center, also known as Shenzhen Universiade Center, Longgang Universiade Center, Sports Center or Longgang Stadium. It is a multi-use sports facility complex in Longgang, Shenzhen, Guangdong, China. It was built by architecture firm Gherkin Marg and Partners. It was opened in August 2021. It is located in Guangdong province in China. So, arch structure. In architecture, arch is an opening in a structure that is curved on top and designed to distribute weight. Arches are self-supportive, compressive structures stabilized by the force of gravity acting on their weight, which makes them very stable and efficient, capable of larger spans and supporting greater loads than horizontal beams. Then dome. Dome is a rounded roof with a circular base, shaped like an arch in all directions. First used in much of the Middle East and North Africa, whence it spread to the other parts of the Islamic world because of its distinctive form. The dome has, like the minaret, become a symbol of Islamic architecture. Dome has double curvature and the resulting structure is much stiffer and stronger than a single curved surface such as a barrel shell. Then pneumatic structure we have and folded plate structure we have discussed in the previous questions in this session itself. So our answer is folded plate structure. Coming back to the image again, it's visible that this is a folded plate structure because there are different plates, triangular shaped plates, which are joined together at different angles to create this very dynamic shape. So our answer is folded plate structure. Question 8. Which of the following stadium uses membrane structure for its roof? National Stadium of Brasilia, Oldenburg Stadium, Germany, Munich Olympic Stadium. All A, B and C. So what is a membrane structure? Membrane structures are structures with a thin flexible surface or a membrane which carries loads primarily through tensile structures. It is a structure which is characterized by tensioning of the membrane system, typically with a wire or cable, to provide the critical structural support to the structure. As per structural and architectural point of view, membrane structures are light and free-form structures to span a long distance with the minimum material used in their manufacturing. Membrane can be used to construct roofs and facades, freestanding buildings, building envelopes, skylights, indoor ceilings and or accent enclosures. So this is how the National Stadium of Brasilia look like. And this is how Oldenburg Stadium, Germany looks like. And this is how Munich Olympic Stadium looks like. So the answer is all B, all A, B and C. National Stadium of Brasilia, Oldenburg Stadium, Germany, Munich Olympic Stadium. US Pavilion Expo 70 is an example of coffer slab structure, air supported pneumatic structure, folded plate structure, inflatable pneumatic structure. So this is how the US pavilion looks like. So the US pavilion for Expo 17 Osaka, Japan. It features a roof covering 100,000 square feet with a clear span of 262 by 460 feet. The total weight of the air supported portion is about 1 pound per square feet. The high strength steel cables up to 450 feet long and are arrayed in a diamond grid. There is no tension ring. In plan, the roof's shape follows the equation of a super ellipse, an ellipse with square corners. So, what is a coffer slab? A coffer slab is a ribbed structure with reinforced ribs in the lower zone, which have mutually perpendicular arrangement. A waffle slab or two-way joist slab is a concrete slab made of reinforced concrete with concrete ribs running in two directions on its underside. The name waffle comes from the grid pattern created by the reinforcing ribs, and waffle slabs are preferred for spans greater than 12 meter as they are much stronger than flat slabs with drop panels, two-way slabs, one-way slabs, or one-way joist slabs. Folded plate structures already explained in the previous questions. Then air supported pneumatic structure and inflatable pneumatic structure. So air supported pneumatic structures, they have higher than the higher than the atmospheric pressure which supports the envelope. Air locks or revolving doors help to maintain the internal pressure. Air must be constantly provided in these structures. The lifespan of these structures is around 20 to 25 years. They are either anchored to the ground or to the walls so that leakage is prevented. They have relative low cost and they can be installed easily. Then what is inflatable pneumatic structure? So supporting frames consist of air under high pressure. The internal pressure of building remains at atmospheric pressure. There is no restrictions in number and size of openings. They have potential to support an attached structure. So the answer is US Pavilion Expo 70 is an example of inflatable pneumatic structure. Question 10. Bahai Temple in New Delhi is an example of dome structure, diagonal structure, shell structure, or pneumatic structure. So, the Lotus Temple located in Delhi, India, also is a Baha'i house of worship which was dedicated in December 1986. It is notable for its lotus like shape. It has become a prominent attraction in the city. The building is composed of 27 freestanding marble clad petals arranged in clusters of 3 to form 9 sides with 9 doors opening onto a central hall. Type house of worship, architectural style expressionist, height 34.27 meters, diameter 70 meters, structural system concrete frame and precast concrete ribbed roof, architects Faribor Sahaba, and structural engineer Flint and Neil COWI. So shell structures and pneumatic structures have explained these terms in the previous answers, and also dome and diagric structures. All these terms have been explained in the previous questions. So the question basically asks that the Baha'i temple in New Delhi, or the Lotus temple in New Delhi, what is it an example of? So looking at this image, this is a curved shell. It's a curved shell structure. Yeah. So the answer is C, shell structure. Question number 11. Which of the following is not a member of a truss? King post, rafter, purlin, or hoop iron? So a king post is a central vertical post which is used in architectural or bridge designs, working in tension to support a beam below from a truss apex above. A rafter is a long board that supports the peak of a roof. So king post is the central vertical post in a truss. Then rafters are kind of a beam which holds whatever above it is building. A purlin is a longitudinal horizontal structural member in a roof, and hoop iron is a multi-use steel strip that is commonly used for bracing non-structural timber and bonding masonry. So this image we see a rafter, purlin, strut, post. All these are rafter. All these are parts of a truss, while hoop iron is not a part of a truss. So the answer is D, hoop iron. Question number 12. Eden project in UK is an example of folded plate structure, pneumatic structure, space frame or diagram structure. So this is how the Eden project looks like. It is a visitor attraction in Cornwall, England, UK. It is located in a reclaimed China clay pit. The complex is dominated by two huge enclosures consisting of adjoining domes that house thousands of plant species, and each enclosure emulates a natural biome. The biomes consist of hundreds of hexagonal and pentagonal uh, ETFE inflated cells supported by geodesic tubular steel domes. The architect is Nicholas Grimshaw. The architectural style is high-tech architecture. The construction started in 1998. It was opened in 2001. The architecture firm was Grimshaw Architects and the service engineer was Arup. So pneumatic structures, folded plate structures, space frames and diagrid, all these terms have been explained in previous questions also, so I will not be explaining them again. So our question was that the Eden project in UK is an example of folded plate structure, pneumatic structure, space frame or diagrid structure. So our answer is B, pneumatic structure. Like it mentions, it's ETFE inflated cells which are supported by geodesic tubular steel domes. Question number 30. The following image is a shell structure which is having the form of paraboloid, hyperbolic paraboloid, cylindric or conic. So the image, I have added the images of all these terms that were mentioned in the question. So what is a paraboloid? A paraboloid is a quadratic surface that has exactly one axis of symmetry and no center of symmetry. The term paraboloid is derived from parabola, which refers to a conic section that has similar property of symmetry. Hyperbolic paraboloid is a saddle surface. Therefore, although it is a ruled surface, it is not developable. Cylinder. A cylinder is a three-dimensional shape consisting of two parallel circular bases joined by a curved surface. Conic. Conic or quadratic curve is a curve obtained from a cone's surface intersecting a plane. So the answer is hyperbolic paraboloid, because this is a saddle shaped structure, because the curvature is in two angles. So the center of both the curvatures is in the opposite directions. So it's a hyperbolic paraboloid or a saddle shape. Then question 14. Following illustration is an example of monoclastic, synclastic, anticlastic or bipolar. So I explained in the previous question, monoclastic means one curvature, single curvature. Synclastic means double curvature, but the direction or the center of the curvature is in the same direction. And anticlastic means double curvature, but the center of the curvature is in opposite direction. So this is how monoclastic, synclastic, and anticlastic look like. So this is anticlastic shape. Question number 15. Folded plate structural systems can be used for roof, wall, staircase, all of the above. So applications of folded plate structures include roof structures. It can be used in roof. Wall structures. It can be used in wall. I have added images of all four types. Floor structures. It can be used in floors also. And staircases. Folded plate structures can be directly used as staircases. So I've added example of all four types of application of structures. So the answer is D, all of the above. Folded plate structural system can be used for roof, wall, staircase. 16. The structural system used in Yokohama International Port Terminal is membrane, folded plate, grid, pneumatic. So this is how the Yokohama terminal looks like. Osanbashi Pier is the main international passenger pier at the port of Yokohama, located in Nakaward, Yokohama, Japan. Osanbashi is the oldest pier in Yokohama, originally constructed between 1889 and 1896. It was opened in 2002. The architects were Alejandro Zaira Polo, Farshi Musavi. The height is 15 meters and the floor space is 34,732 meters square. So this is how the structure, few images of the structure. So our answer is folded plates. The structural system using Yokohama International Port Terminal is folded plate. It's clearly visible. Question 17. The following illustration is a king post truss, queen post truss, Harvey truss, or a Baltimore truss. So a king post truss is a central vertical post used in architectural or bridge designs, working in tension to support a beam below from a truss apex above. A queen post is a tension member in a truss that can span longer openings than a king post truss. A king post uses one central supporting post, whereas the queen post uses two. Baltimore truss is a subclass of Pratt truss, and Harvey truss are opposites of Pratt trusses. So this is how king post truss looks like. One vertical joint from the center, and then two diagonals, and this is how a queen post looks like. Two vertical joints in the middle of the angle rafters. This is how Pratt truss looks like, and Harvey truss is opposite of Pratt truss, and Baltimore truss is a subclass of Pratt truss with having more bracing in the lower half of the truss. So our answer is Harvey truss. This is an example of Harvey truss. I think there might be a little something up with this question. I'll discuss it with the professor, and I'll search on it a little more and then clarify this question, because I think something is a little confusing over here. I'll just clarify it once and then I'll give the solution in the next session. Okay, last question. Pneumatic structure is used in inflatable tea house, Kengo Kuma, Fuji Pavilion Expo 70, both A and B, none of the above. So this is how inflatable tea house Kengo Kuma looks like, and this is how the Fuji Pavilion Expo 70 looks like. So the answer is both A and B. They both are pneumatic structures, and that's all. So this was all for today. Thank you, and see you in the next live session.